Yeah, so good morning. Now we'll start the session for the day. Now, as such, before we start off, we'll just have a very brief discussion on what happened in the last class. Okay, right. Then, if you can able to remember, last class we have started with what was called as the proximity sensor, and we have started with the capacitive type of the proximity sensor. Under capacitive type of proximity sensor, we have discussed first what was the basic equation, that is E is equal to epsilon naught epsilon r A divided by D. And after understanding the basic equation, we understood what are the various different forms of developing a capacitive type of the proximity sensor. Then there some problem occurred with respect to non-linearity. Okay, so in order to come out with non-linearity, we have discussed what was called as the push-pull type of the sensors. Okay, and then after capacitive type, we have discussed what was called as the photoelectric proximity sensor. Under photoelectric, there were two different methods. First one was the reflection type. In that, we will be knowing what is the time taken for the object, for the light to be get deflected. Second one is going to be called as the through beam type. Second one was called a through beam type, wherein you cut the optical axis by having the object passing through the optical axis. Okay, right. Now after this, with this, now we'll just move on to what was the next case called as the light sensors. Okay, right. Just a minute. Be with me. 1 second. Ready. Okay, right. Sorry. Now we'll proceed further with what is called as the light sensors. Okay. Now today we'll just start with our discussion on what is called as the light sensors. Right. So please note down some of the points that I'm going to write. It's going to be helpful to you. Okay. Once again, let me connect the system. Okay. Okay. Right. Now. Okay. Right. Now, in case of this light sensor, basically, in this case, what is going to happen is the basic concept of the light sensor is that the electrical properties, okay, the electrical properties of the material, electrical properties of the material, electrical properties of the material changes, okay, the electrical properties of the material changes when light falls on it. Okay, when light falls on it. Okay, now this is the first thing that we need to understand. Okay, now this is the basic principle on which the light sensor is going to work. Okay, now what are these electrical properties means? Okay, when I say electrical properties, there might be a possibility of what, the change in the voltage, or the current which is passing might change, or there might be what is called as the resistance changes. That means the voltage changes, current changes, or resistance changes may be attributed to what is called as the electrical properties. Okay. Once we say about the electrical properties, then we can able to understand, okay, that we have what are going to be called as now these sensors which show the light are called as, any sensor which senses the presence of the light are called as the light sensor, or they are also called as the photo sensors. Okay, they are also called as the light sensors, are also called as what are called as the photo sensors. Okay. Now the basic principle of the light sensor is that, okay, now the photonic energy, okay, the photonic energy is going to be converted into what is called as the electrical energy. Okay, now this is what is called as the photoelectric effect. Okay, now the principle behind the light sensor is that it's a photoelectric effect where the photonic energy, okay, where the photonic energy is going to be converted into what is called as the electrical energy. The photonic energy converted into electrical energy. Okay, right. Now this is what is called as this. Now what is going to happen is, whenever there is going to be metal which is going to be there, okay, so we have what are going to be called as the particles. Now when the light energy is going to pass on that, you are going to energize this particle and they start to move. Okay, these particles are going to start to move. So this is called as what is called as your the photons, are nothing but what you can consider as the light. Okay, the photons and the light are the light. Now when these electrons receive this energy, that is the photonic energy, they get themselves energized and they start to move. When they move, what is going to happen? There is something called as the kinetic energy of the electrons is going to occur. That means when the charges are going to move, okay, when the charges are going to move, it means that we are getting some amount of the energies. Okay, now this is the basic principle of what is called as the photoelectric effect. Therefore, the light sensors are nothing but what? So light sensors basically are the sensors which senses the presence of the light. They are also called as the photo sensors, right? Then the output of this is going to be some electrical properties of the material. Electrical properties of the material is going to change when light falls on it. Okay. Now those electrical properties may be change in the voltage, change in the current, or change in the resistance. Okay. Now the effect which is responsible for the development of light sensor is called as the photoelectric effect, where photonic energy is converted into electrical energy. Okay. Now in order to develop this light sensor, we can observe, we can have three different effects. Okay. So there are the following are the three different effects. Okay. Three effects. Okay. Upon which light sensors can be developed. Okay. Number one is called as what is called as the photoemissive effect. Okay. Number one is called as the photoemissive effect. Okay. Number two is called as photoconductive effect. Okay. Photoconductive effect. And the third one is called as the photovoltaic effect. Okay. So photovoltaic effect. Okay. Now these are the three different effects which is required, okay, or which is through which we can able to develop the light sensors. Okay, right. Now I just want to know, is this the text is clear to you? Whatever is visible to you, is it clear?
Yes, sir.
Yes, sir.
Okay, fine. Okay, good. Okay. Now these are the three different effects which is required, okay, to develop the sensors. Now if I am going to go with what is called photoemissive effect, the type of the sensors are going to be called as the photoemissive sensors. Okay, now I just want to make it clear. So this is called as the photoemissive sensors. Now this is going to be your photoconductive sensors. Okay, photoconductive light sensors. If it is very particular, photoconductive light sensor. So this is photovoltaic sensors. Okay. Now why I am writing separately is, now in the exam they may ask directly this. Okay, what are the effects responsible for the development of the light sensors? Okay, or they may ask with neat sketch explain photoemissive sensor, photoconductive sensor, or photovoltaic sensors. Okay. Now the effect is photoelectric effect. The sensor, the broad effect is photoelectric effect. The sensor developed is for photosensors or the light sensors. Now under photoelectric effect, we can still observe three different effects, that is photoemissive effect, conductive effect, and photovoltaic. Accordingly, you have photoemissive sensor, conductive sensor, and photovoltaic sensors. Okay, right. Now these are the three cases. Now we'll go one by one now. Okay, so we'll go with what is called as the photoconductive sensors. Okay, right. Okay. Now here, very simple. The concept of photoconductive sensor is, whenever the light is going to strike on the cathode. Okay, whenever the light is going to strike on the cathode. Now wherever the free electrons, okay, whenever those free electrons, okay, receives that the energy, whenever the free electrons receives the energy, it results in increase in what is called the kinetic energy. Okay, it receives in it increases the kinetic energy. Okay, right. Now this concept is what is called as Whenever, sorry, I was there. Yeah, photo, sorry, just missed it. Okay, photo emissive sensors. Okay, right, sorry. Photoemissive sensors. Okay. Now, the concept of photoemissive sensor is whenever light strikes on the cathode, the free valence electrons on the cathode absorbs the light, resulting in increase in the kinetic energy. Okay. Now, this can be applied. Okay. Now, simple. The energy is going to be what? The photonic energy. Energy falls on the material. Okay, and due to which this cathode, okay, the valence electron, okay, absorbs the light energy, resulting in increase in the kinetic energy of the particle. This kinetic energy, these electrons liberated from the cathode are moved towards what are going to be called as the anode, that is the negatively charged particle, resulting in what is called as the anode current, the anode current. Now, the amount of anode current is dependent upon what is the amount of photonic energy which is going to be present. Okay, right. Now, in this case, we have two different types of the photoelectric sensor. Now, we'll just go for the next page. Okay, right. So, two different types of the photoemissives are there. Two different types of photoemissive sensors are present. First one is called as the tube electronic sensor. Tube electronics sensor. The second one is called as second one solid state electronics sensor. Okay, right. Now we'll try to understand. Now this is what is the first one, which is going to be the tube electronic sensor. Okay, so you have what is called as this is your the quartz tube. Okay, we have a cathode material. The light sensitive material is going to be present here. Okay, and then we have what is called as the anode. Okay, now between this and this, I will be having the electric potential. Now to this, what is going to happen is the light is going to fall on this. Okay, so this is your what is called as the light energy. So this is going to be called as the light energy. The light is going to fall on this cathode material. Okay, so now here there are some valence electrons which are going to be present on the cathode material. Now these valence electrons, upon the application of the light, okay, they will get energized and they will start to move. Okay, when these electrons start to move, okay, right, so these electrons are nothing but what? The negatively charged particles. They are going to start to move. They will get attracted to what is this? Okay, right, they will get attracted to this negatively charged anode. Okay, now when there is going to be a movement of the charges to the negatively charged anode, there exists what is called as the anode current. Now I am going to measure this anode current. Okay, measure this. Okay, so this is going to be directly proportional to what is called as the amount of light which is falling. Okay, now this is one method. Okay, that is called the tube electronics method. Now, in this case, what is going to happen is there are possibility that the amount of anode current developed is going to be lesser. Okay, anode current developed is lesser. Okay. Now, in order to avoid this, or in order to make sure that we can able to have a good amount of or a measurable amount of the anode current, we'll be going with what is called as the second one, called as what is called as the solid state electronic sensor. Okay. In this case, just observe, we have what is called as this. Just observe the diagram. Okay, we'll assume this is an area. Okay. Now it's a vacuum chamber. Okay. Now in this vacuum chamber, I am having what is called as a cathode. Okay. Right. Now on this cathode, okay, the light energy is going to be present. Okay. So this is the light energy falling on the cathode material. Now this is your cathodic material. Okay. So this is the cathode, and the light energy is going to fall. Now, as I said, now because of this, the presence of the light, there creates what is called as the electrons. The electrons are going to be liberated from here. Okay. Now, when the electrons are going to be liberated, here in the previous case, what was the problem? The liberated electrons are going to move towards the negatively charged anode. Okay. Here also I will be, if I'm going to keep the same structure, the problem which has occurred in the previous case, here also we are going to get in the second method also. But here what are we going to do now is, we are going to place something called as the dynode. Okay, now please observe here. So we are placing what is called as, I will explain what is this. Okay, now these are called as dynode. Okay, dynode 1, dynode 2, and dynode 3. Okay, right. Now these dynode, okay, are the one. Okay, now this is also called as the photo multipliers. Okay, now this method, this concept is called as the photo multipliers. Okay, now the electrons which are liberated here, will get attracted towards the dynode. Okay, now these are kept at a higher potential. These are going to be attracted towards here, and these dynodes are called as the photo multipliers. This is very, very important. These dynodes are called as the photo multipliers, and due to this presence of the dynode, so they again, okay, the multiplication of the electrons are going to occur. Okay, the multiplication of the electrons are going to occur, and this will be a continuous process. That means, try to understand here, right? Now, when the electrons, the cathode material, okay, right, when the light energy falls on the cathode material, the secondary electrons are going to be generated. Okay. Now, I want to multiply the secondary electrons. I want to multiply the secondary electrons, so that if I am going to have more number of electrons, okay, now when more number of electrons are going to pass us to the negatively charged anode, I am going to get some measurable value of the current. Okay, now further what is that I am going to do is, we have placed what are called as the photo multipliers, called as the dynodes. We have kept the dynode. Okay, so now this dynode will observe the secondary electrons liberated, which is kept at a positive potential than this, which attracts this, and it multiplies the secondary electrons and accelerates the secondary electrons. Okay, now accelerates the movement of the secondary electrons. Then these secondary electrons will be get attracted by the another dynode. Okay, and again it liberates, or it multiplies to have more number of secondary electrons. Then again it comes here, and the number of electrons liberated is going to be large. Then I am going to place something called as the anode here. Okay, now this is what is called as the anode, which is kept at the negatively potential. Then these photo multiplied electron now will get attracted to the anode and get what is called as the negatively charged value. Okay, now what you need to understand here is, without the presence of the dynode, okay, without the presence of the dynode, these liberated electrons, let's say an example I am taking, assume that there are only 2 liberated electrons. These 2 only will go to the anode, resulting in lesser amount of the anodic current. Okay, resulting in lesser amount of the anodic current. Okay, now as we will be having more number of dynodes. Okay, so these dynodes will increase or will multiply the secondary electrons and accelerate towards what are called as the anode. Okay, by which I can able to measure some good appreciable amount of the voltage. Okay, now finally the electrons which are collected at this point, the electrons which are collected at the anode will constitute what is called as the anode current, which is proportional to, now here the anode current, whatever it is developed, okay, anode current developed is proportional to the amount of light intensity. Now, what is that? The basic concept of light intensity is some electrical property is going to change. That is, the value of the current is going to change depending upon the application of the light. Okay, now this is about what is called as the photo emissive sensors. Okay, right. Just observe. Okay, right. Now, once again. Okay, right. This is about what is called as the photo emissive sensors, right? Then, if you go further, second one is called as the photo conductive sensors. Okay. Yeah. Okay. Now, in this, for the case of photoconductive sensors, basically, these are going to be made from the semiconductor material. The photoconductive sensors are made from semiconducting materials. First thing, the photoconductive sensors are made from semiconducting materials. Now, in this semiconducting material, the resistance doesn't ಬೇಗ ಬರಬೇಕು ಹೋಗಿ ಮಾಡೋಗಿ resistance decreases linearly as the light intensity falls on it. Okay, now this is the basic principle of what is called as your photoconductive sensors. Okay, now here the method what we are going to use, okay, in the photoconductive sensors, okay, the materials what we are going to use are going to be called as the cadmium sulfide, okay, lead selenoid, lead telluride, okay, and then lead sulfide. Okay, now these are the materials what we are going to use for the photoconductive sensors. Okay, now these photoconductive sensors are also referred as what are called as the light dependent resistors. Okay, it's also called as light dependent resistors, or it's also called as photo resistor, or it's also called as photo conductor. Okay, right. So please remember this. So it's also called as LDR. LDR is light dependent resistor or photo resistor, or it's also called as the photo conductors. Okay, right. Now, okay, right. Now you just observe. Now I'll just make a simple block diagram here. So this is what is called as the LDR. Okay, that is light dependent resistor material, right? And I'm having two things over here. One is I will place a constant current source, right? Okay, now what is the varying parameter here? What is the varying parameter? I have placed the constant current source. The varying parameter is going to be now, okay, what is called as the voltage. Okay, so positive, negative. So we have what is called as voltage. Okay, right. Now on this LDR material, just observe, okay, the light energy is going to fall. Okay, right. Now this is what is called as the light energy. Now a very basic understanding of this light sensor is, now as we told that the resistance is going to change. Resistance changes. Okay, V is equal to I into R. Okay, right. Now in this case, I have made as what? Constant. Okay. So I have made as constant. Okay. So this is a constant current source. Then as and when the resistance changes, this change in resistance will make the voltage to change. Okay. So now according to this, the V is proportional to what is called as R. Okay. Right. Now the basic principle of the photoconductive sensor, as I told in the beginning itself, that it is made by through such a material wherein the resistance of the material is going to change when the light falls upon it. In order to make that, okay, we have built a LDR circuit, okay, LDR circuit with LDR material, maybe any of the material that we have discussed, okay, lead telluride, lead sulfide, or antimonide, whatever it is. Then when a light falls on it, okay, what is going to happen is this LDR, the material of this LDR, the resistance of which is going to reduce. When the resistance is going to be reduced, okay, now if the LDR is made a part of the electric circuit, this change in the resistance, okay, this change in the resistance should reflect either in the change in the voltage or either in the change of the current. Okay. Now, what is the circuit that you have made? You have made the circuit like the constant current source. Okay. So you have made the circuit as constant current source. Therefore, the change in the resistance will make what is called as the voltage to change. Now here, what is the parameter which is going to be there? What is the varying parameter? It is the change of voltage. Okay, it is the change of voltage is what is your output. Okay, the change of voltage is going to be your output, and the input is going to be what is called as the amount of light intensity. Okay, now the increase or decrease in the output voltage, the increase or decrease in the output voltage is a measure of, okay, is a measure of what is the amount of light intensity which is going to be present. Okay, so this is something related to what is called the photo conductive sensors. Okay, right. Then last one we have is what is called as the photovoltaic sensors. Okay, so we have what is called as the photovoltaic sensors. Okay, right. Now you can have the two different methods here. Okay, in this case, what is called as, one is called as your photodiodes. Okay, and the other one is called as the photo transistors. Okay, so you can have photodiodes or phototransistors. It means the material is, if you are going to use a diode, okay, so it's a photodiode, or you can use what are called as the transistors, then you call it as the phototransistor. In phototransistor, you can still expect what is called as the NPN transistor method, or you can expect what is called as the PNP. Okay, right. Now in the first method, okay, that is what is called as the photo emissive method, the electrons are going to move and attract towards the anode, resulting in the anode current. Okay, in the second method, that is the resistance of the material changes, and you can either make the constant current source or the constant voltage source. But the diagram, what is that I have told now is, you have made the constant current source, hence you have measured the voltage. Okay, if you make the constant voltage source, if you give the constant voltage source, or if you maintain the constant voltage source in the circuit, then you are going to measure the current. Okay, right. But in the case of photovoltaic sensor, the principle is simple, that there exists what is called as a potential difference. There exists a voltage across the material because of the incident light. When the light falls on it, the electrons are going to be developed, the electrons are going to be generated, which results in the potential difference. Okay, so this is the basic principle of what is called the photovoltaic sensors. Okay, now if I am going to consider what is called as the photodiode, okay, so I will be using what are called as I think you can understand this diagram. So this is the diagram of what is called as the diode. Okay, right, this is the diode. Okay, right. Now this is your the photodiode, or the semiconducting material. They are placed in the form of diodes. Now this is nothing but the light falls on it, and I will be having what is called as the current, which is going to be generated. Okay, right. So you pass on the current increases as the light intensity increases. Okay, now this is with respect to the photodiode. Okay, or you can still say it is nothing but what is called as only P and N type. Okay, so you have what is called as anode. Okay, so you have what is called as the cathode. Okay, so this is development of one such particular sensors. In the other way, you will be having what are going to be called as the two cases. One is your P and another is P and P. Okay. So in this case, what we'll be having is, so how many things are going to be there here? We have emitter, and you have the collector, and you have the base current. Okay, right. Now what I mean to say is the other one is going to be either your NPN transistors. Okay, right. Now the material can be same, that is the development of your photovoltaic sensors. Okay, is going to be either based on the photodiode, using diode as the connecting element, or through the transistor as the connecting element. Okay, so this photo transistor, okay, if it is going to be a photodiode, if you observe, so the photodiode is the one wherein we will be having PN junction, okay, specifically designed for light detection. Okay, now in this case, the photodiodes are going to be connected in this particular fashion. When the light falls on it, there is going to be increase in the voltage you are going to get. Okay, because of the you know that in case of your the diodes, okay, the resistance of those is going to be reduced when the light falls on it. Okay, so that concept we are going to utilize here, and utilize it for the development of the photovoltaic sensors. Similarly, we have what are called the phototransistor, which you know that we have three different layers. Okay, either PNP layer or the NPN layer. Okay, now we have neglected the amount of base current here, taken only emitter and collector. Okay, on the junction. Okay, so accordingly, we'll be getting what are going to be called as the type of the energies. Okay, right. Now these are the methods of light sensors, okay, which we can able to consider, okay, either with the concept of emissivity, or with the concept of what is called as conductivity, or with the concept of what is called as the photovoltaic. Okay, right. So these are the three different types of the sensors, okay, which are going to be present for us to understand. Okay, right. Then we'll go further now. Okay, right. Next we go with another simple type of the sensor, okay, which is called as the strain gauge based sensor. Strain gauge based sensor. Okay, right. Okay, now what are strain gauges? What is the principle of strain gauge? What is the principle of strain gauge? Can anybody say? You are there at least. What is the principle of strain gauge? What for strain gauges are used? Hello? Pawan? Anybody answer?
So it is a type of sensor.
Huh?
It is a type of sensor.
Okay, what for it is used?
It is used to
measure small
convert
displacement.
force into a change in electric resistance.
Okay, what are the different types of strain gauges? Any idea? Anybody? What are the different types of strain gauges? Prince Stronger? Roshan? Nilesh? Dheeraj?
Yes, sir.
Here, strain gauges.
What are the different
It's a
types?
linear strain.
Huh?
Linear strain gauge.
Okay. Then
It's a full bridge,
okay.
half bridge, shear strain gauges.
Shear strain gauges. Okay. Then depending upon the the shape of the strain gauges? Any idea? Depending upon the shape of the
So
strain
wire
gauges.
type.
Yeah, yeah, good, good, good. Okay, wire type and one more.
Bridge strain gauge.
One more.
Foil type, sir.
Foil type. Okay, so we have some concept of the strain gauges that is known to us. So basically, strain gauges are the electrical type of the members, transducers, which are mainly used to determine the smaller amount of the displacements. Okay, small amount of displacements are going to be used, are going to be picked up by this the strain gauges. Okay, generally these strain gauges are going to be called as the resistive. Sorry. Okay. These strain gauges are going to be called as the resistive. Okay, so these are called as the resistive pickup type transducer. These are called as the strain gauges are called as resistive pickup type of transducers. Okay, now in this case what is going to happen is, so if you have understood the basic concept, now we have made it as the 4 resistors of the Wheatstone bridge network. Okay, so this is one method by which you can have your the strain gauges. So one of the resistance is going to change. That means what basically? Okay, now okay, right. Now you know that in case of a strain gauges, the resistance of the change, the resistance of the strain gauges changes in accordance with the load which you are going to apply. Okay, the load may be a force or something else. Okay, now you are going to apply a load onto it. Then if you apply some strain gauges, okay, let's say in case of your the load cell we are done, okay, or a simple load cell experiment we are done, okay, right, wherein you place the strain gauges at the 4 different corners. Okay, or the other possibility is going to be, maybe I want to measure the force here. Okay, a cantilever beam I have kept. Okay, so I have kept what? I have kept the 4 different strain gauges over here. Then you are going to apply the load. When you are going to apply the load, this load is going to be picked up by the strain gauges. Okay, and this load is going to be taken into what is called the Wheatstone bridge, and the resistance of the strain gauges is going to change. Okay, so when the resistance of the strain gauges is going to change, okay, now that will have an impact on what is called as the value of the voltage. Okay, so that is the basic understanding. Now in this case, now generally strain gauges are going to be a small thin shaped material. Okay, but it's a thin metallic filament, we can say a thin metallic filament. Okay, which is generally from 0.002 to 0.05 millimeter thickness. So I am going to use a simple resin. Okay, so right, and I am going to paste it on this material. Okay, so this is your what is called as a strain gauge. Okay, so you use what is called as the resin to paste this onto the member for which you want to determine the strain. Okay, now this is the member for which I want to determine the strain. So I applied the load. Now I don't, it is not possible for me to use extensometer. I think you know there is something called as extensometer. Okay, so this is what you have used in your the material testing lab. Okay, so extensometer is going to be used to determine the strain which is in the particular range. Okay, but if the amount of strain is going to be very small, okay, that we call it as micro strain. If the strain is very smaller, change in length by original length, if it is very smaller, it is not possible for the extensometer to the pick. Okay, therefore we generally use what are called as this a small element called as the strain gauge. Okay, now the principle involved, okay, in the strain gauges is, as I said, the resistance is going to change. Okay, now this fractional change in the resistance, okay, that is change in the resistance to the original resistance, that is called as a fractional change in the resistance, is proportional to what is called as the strain. Now you know this strain is because of the load that you applied. Because of this strain, the change in resistance has occurred. Okay, now if I am going to take out this proportionality constant, okay, so this is what is called as delta R by R is what is called as G. Okay, and E. Now you know that, okay, if you remember, G is nothing but what is G? What is G? What is G called as? What is the proportionality constant G called as? Any idea? The proportionality constant G is called as the gauge factor. The gauge factor is nothing but change in resistance to the original resistance divided by strain. So you know that strain is called as what? Strain is called as change in length to original length. Now this is the principle of what is called as the strain gauges. That is, the strain gauge is the strain will make the resistance to change with a proportionality constant called as the gauge factor. Now gauge factor is nothing but a factor which is for a particular material. Okay, right. So generally gauge factor for the metals, okay, is going to be considered as 2. Okay, now if you remember, now in the experiment that you have done in the 4th semester, so you have set it to 1000, you have set it to 500, if you remember. Okay, right. So 1000 is nothing but the maximum strain that can be occurred. Okay, why you have set it to 500 is you have used what was called as the mild steel. Okay, if you remember, you have used mild steel. So mild steel is what is called as the metallic material. The gauge factor for this is going to be 2. The value of G is going to be 2. That is why this 1000 divided by 2 is 500. This is what is the value of the strain that you had set at that moment. Okay, so just remember that. So G is nothing but what is called as a gauge factor. Okay, now to have a look at the strain gauges are nothing but what they are called as the resistive pickup type of the transducers. Now in this case, the resistance of the strain gauges changes in accordance with the load that you are going to apply. Okay, so they are the small thin filament which is going to be bonded or which has been pasted onto a surface for which you want to determine the strain. Okay, now the basic principle involved here is the change in resistance to the original resistance is proportional to what is called as the strain. Now the proportionality constant is called as the gauge factor, that is called as your G. Okay, right. Now as we have mentioned, okay, now strain gauges are generally used for what? Okay, the strain gauges are used to measure the displacement. In turn, you can use it to measure the forces or the torque, etc. Okay, now we will be having the 2 different types of strain gauges, which are wire type or the foil type. Okay, which one do you prefer? Wire or the foil type? Okay, we have 2 cases: wire type, okay, and what is called as the foil type. Okay, right. Now which one are we going to prefer generally?
Wire type.
Huh?
Wire type, sir.
Why? Okay, now I'll just write. Okay, so wire type is going to be like this. Okay, right. Foil is going to be something like this. Okay. Okay, right. So this is the member, right? Just observe. Okay, so this is going to be wire type and this is foil type. So this member you are going to place it on the surface. Okay, right. When you place these, either the wire or the foil type on the surface, which type of strain gauge will be having more amount of contact with the surface?
So foil type.
Foil type. Okay, so which the, now we know that because the load has to be sensed by what? The load has to be transferred. Okay, transferred. Okay, very clearly. That is, the load has to be sensed by the strain gauges. Okay, so it can able to sense if it has adhered or if it has bonded to the member in a proper manner. Because as you are going to use a wire type, the bonding is going to be what? The bonding is going to be in a smaller area. Means what? If I take a wire, it is on a line. Okay, correct? No? Okay, if it is a ball bearing, it's a point contact. If it is a roller bearing, it's a line contact. Okay, so in a wire type, one of the point lines, okay, is going to be in contact. But in foil type, what is going to happen? The surface is going to be the foil surface. The surface of the strain gauge, which is foiled one, is going to have a contact on the surface. Therefore, the foil type is going to be better because of more surface area. More surface area is going to be get contacted. Okay, now what are the applications that you can consider? Okay, is going to be, as I said, I can make use of this. Okay, right. Now what is this diagram? Can you able to guess? I'm just writing, just right. Okay, so there is something like this. Okay, right. So what is that I am showing is, okay, and generally consider it as a resistive pickup. That's why we will take it as Wheatstone concept only. So hence I will be having 4 different types of the strain gauges. Okay, right. Now what is this? This is used for what? Any idea? Anything that you observed in your previous observation? For measurement of what? Okay, now this is the basic concept is your proving ring. Proving ring is used for the measurement of proving ring. So this is proving ring. Okay, if you are not getting properly, this is proving ring. Okay, so this is mainly used to measure the force. Okay, or you can also have your what is called as. Have you come across with photoelasticity experiment in your design lab till now? In your
No,
design, photoelasticity experiment has done?
No, sir.
No. Okay, fine. Okay, now there is something called as a photoelastic member. This is what is that I wrote is the photoelastic member. Now I will be having what is that? Okay, now this. Now this, if I'm going to compress, okay, if I'm going to compress this, okay, means if I'm going to apply a load onto this, okay, load onto this. Now this elongation is going to be picked up by these sensors, okay, right? So these what are called as the strain gauges, which is used for the displacement. Okay, that is, you can make use to measure the displacement or what are going to be called as the force. Okay. Now this is generally we use it for what are called as the strain gauges. Okay. Right. Now this is about the strain gauges. There is one small bit which is left out called as the encoder. Okay. Just remember this encoder. If time permits, you just try to have some information about this encoder. So this will try to understand in the next class. Okay. Right. Now to summarize, okay, so today we are just done with what is called as a light sensor. Okay, now the concept of light sensor is the photoelectric photoconducting effect. Okay, or the photoelectric effect. Okay, now under photoelectric effect, photon energy converted into the electrical energy. So photoemissive sensors, photoconductive sensors, and photovoltaic sensors. Okay, then later on we have discussed what is called as the 3 different methods. Okay, which is called as the strain gauges, which is mainly used for measurement of the force on the torque. Okay, right. So I think we'll stop at this stage. Okay, so I request you to type your USA number, okay, before we close the class. Please type your USA number and we'll continue the class